121 lab students. This is lab 3, separation and analysis of a mixture. Make sure that you record the unknown mixture number when you see the demonstration part of this lab video. The mixture we're going to have is going to consist of ammonium chloride, NH4Cl, silicon dioxide, SiO2, which is sand, and sodium chloride, NaCl. We're going to have a little bit of a modification of the procedure. So when we are going to filter off the sand and collect the salt water, we're not going to use it in an evaporating dish. We're just going to use it in a beaker that will allow us to speed up the demonstration video. This is one of Professor Hammond's tricks, right? So we're going to be taking advantage of different physical properties of these different compounds today. The first one is that the ammonium chloride will sublime when heated. When we heat that, then we're going to be able to separate it from the mixture. When we're doing so, he's going to use a Bunsen burner, so he's going to talk about how to use the Bunsen burner. You also want to kind of make sure that when you put your unknown mixture into this beaker that you spread it out so that when it gets heated, it can liberate all of the ammonium chloride. The other physical property we're going to take advantage of is to separate the what's called the residue, which consists of the sodium chloride and the sand, the silicon dioxide, is take advantage of the solubility of sodium chloride in water, right? So the way we're going to determine our masses of all of our readings in this lab is to measure the weight by difference. So for example, if I have the beaker plus the unknown and I subtract just the mass of the beaker empty, I can get the total mass of the unknown mixture. When we're heating the material to sublime the sodium chloride, or excuse me, ammonium chloride, we need to heat it until we get a clearing around the side of the beaker so that we can then wipe off the deposited ammonium chloride that will coat the surfaces of both the watch glass that we put on top that prevents any material from spilling out or popping out, and also on the cooler sides of the upper part of the beaker. And so we'll take a wet paper towel, you'll see Professor Hammond, and then wipe that out. And then we're going to heat it a second time, right, to make sure that we got all of the ammonium chloride removed from the mixture. A couple of safety notes is that, of course, if this thing is hot because we've been heating it with a Bunsen burner flame, we need to make sure that we cool it before wiping off any of the ammonium chloride. We also need to make sure that we cool it before we weigh it in the analytical balance. If you weigh it in the analytical balance, it'll actually cause a vortex of air, which will make the object appear lighter. The next thing we're going to need to do is we're going to determine the amount of ammonium chloride that we sublimed or removed from the mixture by taking the difference of what we call the beaker plus the unknown minus the beaker plus the residue, which is after heating to remove all the ammonium chloride. Next thing we're going to need to do is we're going to need to set up a filter with a piece of filter paper so that we can take advantage of the fact that the salt will dissolve in the water and separate the sand from the salt. So what we're going to do is fold this piece of paper in half and then in half again until it becomes like a quarter of a piece of the round circle. And then we open up one pocket to make sure that we can filter out the sand from the sodium chloride. When we put wet water on the paper with the salt and sand in it, the salt water itself can adhere to the paper, so you're going to end up having to rinse the paper 3 times to remove any of the salt water that would adhere to the paper. We're going to then take the filter paper and we're going to put it into the drying oven on a watch glass, the watch glass that we used up above. We're going to heat the salt water to remove all of the water, and so as the water boils away, the salt residue will stay here, and as the salt starts to form, we can get what is known as popcorn effect, where the water coming off of the salt crystal kind of vaporizes and causes the material to splatter around. So we'll turn the temperature down to make sure that we minimize the amount of popcorn effect of the salt crystals popping out. But we have to continue to heat this beaker until we get all the water droplets that might also condense on the cold parts of the glass up above. And then once we're done with that, we can weigh the beaker plus salt and take the mass by difference. And the same thing with the sand. If we know the mass of the filter paper when it was empty, and we know the mass of the filter paper after it's been dried, we can get the mass of the silicon dioxide. That's pretty much it for this lab, and thanks to Professor Hammond for doing his little tricks to make the lab go by rather quick. I'll see you next time. Bye.
Welcome, students. Today we are doing experiment 3, the separation of a mixture of compounds. The first thing you're going to do today is actually obtain an unknown vial and very carefully record the unknown number. This one happens to be number 18. Your grade will depend on how precise and accurate you obtain the correct mixture ratio of the 3 compounds in this vial. So the first thing we do is we're going to do some weighing. We're first going to weigh a beaker empty. This is your large beaker. Very carefully. I'm going to pause for a second. Record the mass. Alright. Then we're going to take all of our unknown in this unknown number 18, pour it into our beaker that we just weighed. And then we're going to weigh it again. And the difference of the 2 weights, okay, very carefully record that mass. And that will be the weight of our starting unknown material. Next, we're going to set up a Bunsen burner apparatus, but before we do that, we need to demonstrate the proper use and technique of a Bunsen burner. These are the Bunsen burners we prefer to use in our lab. They have 2 moving parts. The column here, as you unscrew it, lets more and more air into the mixture, as you can see here. As you can unscrew it actually too far and the column will separate. Please do not do that when you use your Bunsen burners. Now the easiest way to light a Bunsen burner is actually to close off all the air. When you do that, it does not allow much mixing of air until it reaches the spout. It's a much easier flame to light. Now the other valve you need to use on a Bunsen burner is this needle valve. It actually controls the amount of gas that goes through the chamber. Again, the easiest way to light a Bunsen burner is first turn it off, or turn it clockwise, then turn it back 1 turn. Now that I've turned it back, we are ready to light the Bunsen burner. There are 2 ways. One is to use a sparking device. You should see a spark when you push the flint across the steel, and it usually takes 1 or 2 sparks to ignite the gas. The other way is, of course, to use matches, but eventually use them all up. The sparkers just won't work. So we will use a sparker. I'm going to move the Bunsen burner a little bit into view. We're going to reach back, turn the gas valve on a full turn, and when we spark, the flame jumps right up. You have a bright yellow luminous flame. This is not the flame we want because it'll put charcoal and soot all over the bottom of our beaker and change the weight. Now we're going to adjust the flame. First I'm going to open up some air. As I open up some air, the yellow flame diminishes and it goes to a bluer flame. And I'm going to decrease now the gas flow a little bit on the high side. I want a lovely bright blue cone. I'm going to hold my hand behind it so you can see that I have an intensity cone. And we're now going to pull our beaker with our unknown mixture. It's already sitting on our ring stand. We're going to put a watch glass on top, just as a safety precaution, try to capture as much of the ammonium chloride. Now, our Bunsen burner is, the tip of the flame is just touching the bottom of the beaker, which is exactly where we want it. Today is a little bit humid, and you should see that immediately there's kind of a steam-like appearance. We don't want that. That's going to all go away eventually. But what will happen is as the bottom of the beaker becomes hot, our ammonium chloride is the only compound of the three that can sublime. So I'm going to try to defog this part of the glass. You can actually see that we're starting to form a smoky-like appearance. As the ammonium chloride turns into a gas, because of the heat, as soon as it reaches something cool, it turns back into a solid. And the solid in the air is actually what gives us a smoky type appearance. Now, what our goal is to remove all the smokiness out of the bottom and let the ammonium chloride recondense on the cooler parts of the glass. We can see this, it's smoking pretty heavily. I'm going to bring the exhaust fan over just for a moment. Make sure we do not accidentally set off fire alarms again. No laughing. I'm actually going to turn this spout over towards the side. Alright. Now you're going to see through the video that the white is starting to cake along the sides and get more and more opaque with it. And that is a good sign. That's what we want to see. We want to see the ammonium chloride re-solidifying up on the sides and on the bottom of the watch glass. So what I'm going to do now is I'm going to hold it on the side that's closest to you. And here is the important part of this lab. We have to make at least a 1-inch gap of clear glass around the bottom of the beaker. To illustrate what I mean by that, I'm going to hold the Bunsen burner now sideways. I'm going to put it right there on the glass. Glass is not a very good conductor of heat, but as I put it right there on the gas, I created basically a 1-inch gap of ammonium chloride. Now we're going to need a gap that large all the way around the entire beaker. But we still have smoke coming off the bottom, so we're not quite ready to start making our 1-inch gap. So we need to keep the bottom really hot. And make sure as much of the ammonium chloride is sublimed as possible. Backside. Right now, on the sides away from the camera, we have about a 1 centimeter gap. I like it to be closer to 1 inch before we go to the next stage of this experiment. Okay, it appears that most of the bottom is no longer smoking. Now, we're going to do this twice, so I'm now ready to start making my 1-inch gap all the way around. I'm just heating the bottom corners of the beaker. And we will look around to the backside, make sure there's a gap there. And one of the nice things about these particular Bunsen burners, as long as you don't touch above here, it stays relatively cool. All right. Okay, we will now let this cool for 5 minutes. Alright, we have now waited the 5 minutes to allow this beaker to cool down, so we can now try to remove the ammonium chloride. One of the nice physical properties of ammonium chloride is it's much more water soluble than any other compound. In fact, we only need a very slightly damp paper towel and the ammonium chloride will dissolve right off. See how nicely that dissolves off? So we're going to do the same thing inside the beaker, and we're going to avoid touching the bottom of the beaker. That's why we have the 1-inch gap. So I'm going to lower it down, and I'm going to slowly wipe off the ammonium chloride. Okay, we have now removed the ammonium chloride, and we're ready for our second and final heating of this mixture. Want it as clean as possible. Okay, so we're going to relight the Bunsen burner. Just to make a comment, if we've adjusted nothing, we should be in the perfect flame that we turned it off at. I'm going to show you the other lighting technique, which is done with the matches. To light with the matches, again, you turn on the main spigot, strike the match, and you very carefully bring it to the edge of the Bunsen burner. And it should be the same flame that we had before. And we're now ready to cook the bottom one last time. Today is a very humid day. So because we removed nearly all, if not all, of the ammonium chloride on the first time, the amount of smoke or smog we see should be minuscule or non-existent. I'm going to put flame heat it where it's the thickest over here on this side just to see if any smoke comes out at all. I'm going to make the bottom of the Bunsen burner kind of glow red. You can see the nice glowing in the film. If I look closely, I'm beginning to see a faint haze going around the beaker. So there was a trace amount of ammonium chloride there. Not very much, not as we did remove most of it the first time. And so I'm going to try to drive that haze up the side. So just like on the first time, we need an inch of clear glass with no haziness. Okay, we have our 1-inch gap. We're now going to turn off the Bunsen burner. And again, we're going to let it cool for about 5 minutes. But before we turn it off, you should notice that there is a faint haziness on the top part of the glass. That is the final remnants of our ammonium chloride. So after this cools, we'll wipe it one more time and we'll go to the next phase of our experiment. Alright, we have now waited the 5 minutes of cooling. We are ready for our final wipe down of the ammonium chloride. Again, we're going to use a damp paper towel. And again, it's important to not touch the bottom. That's why we had the 1-inch gap of clear glass. It looks like now our beaker is ready to be weighed. So that is the next step of our experiment, is to make sure this is cool enough that it won't change weight when we put it on the scale. One of the questions I ask my students, does a hot beaker weigh more or less than a cold beaker? I'll let you think about that for a second. Or does it weigh the same? You get three choices. And the truth of the matter is, if there was no air, it would weigh the same. But because there's air, hot air always rises up the sides, and if it doesn't fast enough, part of the way the beaker will actually be lifted right off the scale. So to avoid that, we got to make sure it's basically room temperature, and it is, before we weigh it. All right, please record this weight. It should be a little bit less than what it was when I put the entire unknown sample. And we're going to make the assumption that all the weight that was lost from the previous weight to this weight is ammonium chloride. So we now know how much of our unknown was ammonium chloride. The next part of the lab is to try to separate the two compounds that are still inside. I'm going to see if I can tip it over, but you see there's a pile of sand and sodium chloride in there. They're mixed together. So to separate these two, we're going to take advantage of a physical property called solubility. The solubility of sand in water is, for all intents and purposes, nothing. Sand never dissolves in water, whereas the solubility of salt is pretty high, and we can eventually dissolve all the salt out of this mixture if we use some water. But before we do that, we have to weigh two more objects. Now, for today's experiment, in lieu of an evaporating dish, we're going to weigh this 150 ml beaker. So on the line that says evaporating dish, please record this mass. This is the beaker in which we're going to capture the filtrate, which will be the water and the salt, or our salt water. Can we see that number clearly? 6.484. Okay. All right. Now the other thing we need to weigh is a piece of weighing paper. In the weighing paper, or filter paper, sorry, this is filter paper, we're going to create a cone shape by folding the filter paper once and then twice. Now, some people say you're supposed to tear the corner. I never recommend doing that. So I folded the filter paper. Let's now weigh it. And where it says filter paper in your notebook, please record the weight of the filter paper. Can we see that number? Very good. Okay, now to set up our filtration. To set up a filtration, we're going to bring a funnel into view. Just a regular funnel. It can be glass or plastic. And if we peel the paper back, it makes this cone shape. And we're going to put our beaker that we weighed just a minute ago into there to capture water. So I wetted it down with some ultra pure water to now filter this mixture. So there's a couple ways you can do this. One of the easiest ways is to actually just pour all of the sand and salt in dry. Then use your squirt bottle and rinse out the sides multiple times. So you see the sand has collected there at the bottom of the filter paper, and we have water in there. Now I'm going to reset this straight up. You're not going to be able to see down inside for a moment. But we want to make sure we have everything out of the first beaker. So I'm going to do one more rinsing of the first beaker. Alright, you see the liquid is collecting down at the bottom. That's where our water is dripping. There's water in the top, and here is one of the questions that's always in the homework. Where does the sodium chloride go? Well, you'll say he goes into the water. Where does the water go? The water happens to go everywhere down here, but it also happens to soak into the paper. Because the water is soaking into the paper, guess what else is being soaked in the paper? That is the sodium chloride. So the sodium chloride is in the paper, and what we're going to do is we're going to attempt 3 washes. A wash step is basically a step where we try to rinse and purify whatever solid we're collecting and rinse out any of the soluble ions and other compounds. In this case, we're going to try to rinse out any soluble sodium chloride. To do a complete rinse, you take your pure water and you squirt the very top edge of your filter paper, just gently, one time all the way around. And as you squirt the top edge, the fresh water should push any salts down towards our filtrate on the bottom. And we let that settle, or drain, in other words. Alright, and now we're just going to let it drip until, or continue dripping until we don't see it drip anymore. Now that we've done that, in theory, with 3 rinses, all of the sodium chloride should have been removed, and hopefully will end up down in the filtrate in this beaker, which we weighed previously. So we're just going to wait for this to drip, and then our last step is to remove the one impurity left. So what impurity is left in our compound? If you guessed water, you're correct. So we have to remove all the water that's here, and we have to remove all the water that's soaked into our paper before we can do any more weighing. Okay, it appears it is finished dripping. So we're going to take the watch glass that we used before. We're going to very carefully transfer the filter paper to the watch glass, like so. We're going to go place it in this oven that's back here in the background. The oven is set at 130 degrees, and it should completely evaporate any water if we give it enough time. Now what's left in here, look closely, is a nice clear solution that should have captured all of our sodium chloride dissolved in the water. So we are going to now begin to evaporate that. And we'll set this here. We'll crank the heater to high. Okay, you see the white foaming occurring? That's the beginning of the formation of the sulfate. There's not enough water to stay dissolved. We're going to turn this from high to a nice medium heat. And we see here, and we can hear final of the popping. But we're not done evaporating because the bottom is mostly evaporated, but we still need to evaporate the sides. That'll take approximately 3 to 5 more minutes. And now we're getting a lovely popcorn effect. Okay, it appears that the beaker has finished drying. There's no more water droplets easily visible. So we're now going to just set this down for a moment to cool. And while that's cooling, we can go over to the oven and clean our filter paper in our pan, and it should be nice and dry as grit also. We're going to put that right there. Now these cool off fairly quickly because there's no liquid inside. Yep, that one's about ready. Yep. And this one, all nice and dry. So let's do the filter paper first. Not very hot, so first stick here. Okay, so this is our sand plus filter paper. Check the number. All right, record that in your notebook. And you can see the sand is still in the bottom of our filter paper. And now we're going to take the beaker, which is in lieu of the evaporating dish. So this is our beaker plus our salt that goes on the line with the evaporating dish. Can you see the number clearly? Record that in your notebook. We have finished recording the data, so now we have successfully separated the salt from the sand, from the ammonium chloride, and you should be able to do all the calculations.